The CLO for today's lesson is students will be able to evaluate in writing functions using function notation, graphs and tables, in the following language: if-then statements, input and output. So, in your own words, what do you think you're going to learn how to do in this lesson? All right, so let's start with the vocabulary at the end: input and output. So input is what we put into the equation. Now, when we put things into equations, we always plug them in to what letter? Do you remember? Like if I were to say plug in 5, what are you plugging 5 into each time? X. We always put things into X. So X is our input spot. So anywhere in an equation that you see X, it means put things in here. So that's input. Output, then, is what we get out of the equation, also known as the answer. Because once we put something into the equation, math will happen, and then we get out an answer. And what letter is the answer? It's a Y. So once I put something into this X, I'll do math to it, and then I'll get an answer out, and that's my output. So those are just big words for what we put into and what we get out: input and output. So let's look at an example here. So this question says, what is the output if the input is 5? So right now, which one do we know? Do we know what X is, or do we know what Y is? Remember, input is X, and it says input is 5. So that means X equals 5, because is the same thing as equals. So in a word problem, wherever you see the word is, you could always replace it with an equal sign. So X is 5. The question is what is the output? But output means what letter? So it actually is asking what it is Y. If X is 5, what is Y? Another way to say that in easiest terms is plug in 5 to X. If I do that, I have Y equals 3. Instead of X, I'm going to put a parentheses and then minus 4. And what number do they want me to put into that parentheses? 5, because it says X equals 5. And then to figure out Y, I just have to do the math. So remember, in order of operations, we have to do what first to the 5? Do I times it to 3 first, or do I minus 4 first? Multiplying comes before subtracting. So first we do 3 times 5. And 3 times 5 is 15. And then you have minus 4. And now if you do 15 minus 4, you'd get 11. So the answer, and I'm going to say it very mathematically with my if-then statements from my CLO. So there's a rule in math that if they ever ask you a question in words like this, you must respond to them in words like this. This answer would not be enough because they asked with words. You have to respond with if the input is 5. So see how I started with the end of the sentence? And that's kind of how I started it. If the input is 5, then we're going back to an if-then statement. You start with your if something, and then you say something else. Then what? Well, then the output is 11, because my answer at the end was that it was Y equaled 11. So that is how I would respond to this question. So this is an easy type of equation because all I had to do was put the X right here in parentheses, and it's 3 times X. But there are advanced equations. They expect you to know what they mean. I'm going to teach them to you just in case you don't know. So this guy here, when you see an X with 2 lines around it, it has a name. and it's called absolute value. This is the absolute value of x. If there's something else in there, like a +1, then it would be the absolute value of x plus 1. But right now, it's just the absolute value of x. And what it does is it makes the final number positive. So what the little lines on the outside tell you is once it's down to one number only, like for example, let's say it was -2 inside absolute value sign. Well, what absolute value does is once it's down to that final number, it makes it positive. So instead of -2, it becomes +2. Same thing if it was, let's say, I had just +5 in there. Well, the rule is that it makes the final number positive. So since it's already positive, it just stays positive. So I'm going to just do one more example with some math in it. Let's say it's 7 minus 3 on the inside. Well, that answer equals, it's important, remember that it's about the final number. It doesn't just turn this into a plus. It doesn't become 7 plus 3. You have to do 7 minus 3 first, and 7 minus 3 becomes 4. Then you make the number on the inside positive. Well, it's already positive, so the answer is just 4. So that's why it's important to do the math first, make it one number, and then absolute value just makes whatever's on the inside positive. And note that once I made it positive, the absolute value signs, they went away because I did its job. I took the absolute value by making it positive. So the lines don't have to be there anymore. This is another advanced equation. It's called x squared. There's also 1,000 other ways to say it because this is something called an exponent when it's a tiny number in the little upper right-hand corner. So they might say x with an exponent of 2. Sometimes they call exponent degrees, so they might say x to the degree of 2. And they also call them powers, so they might say x to the power of 2. So these all mean the same thing as x squared. The x squared is the main one. So what it does, x squared means take a number and multiply it to itself. If we don't know what that number is, then it means it's x times x. So x squared means whatever x is, it's times to itself. So a couple examples. I could do 3 squared, and that means I do 3 times 3, and 3 times 3 is 9. I could also do -5 squared. That just means I take -5 and times it to -5. And what's a negative times a negative? Positive. And 5 times 5 is 25. The interesting thing here is that both of these answers are positive because a positive squared is still positive and a negative squared is still positive. So this is squared. And then the next one they expect you to know is x, where the exponent up here is a 3. So the fancy word for it is x cubed because anything with a 3 usually has the word cube in it. So that's one way we read it is by saying x cubed. But they could also use all 3 of these ways just with the number 3 instead. So it could be x with an exponent of 3, x to the degree of 3, x to the power of 3. But x cubed is the fancy special name for it. And the rules are the same. You take a number and you multiply it to itself, but this time it's 3 times, not just the 2 times. That means there's 3 of them being multiplied to itself. So if I did an example, 2 cubed means 2 times 2 times 2. But there's 3 of them. And then 2 times 2 is 4, times 2 again becomes 8. Also, if I go into Desmos and did 2 to the power, or to the exponent of 3, you see how the answer is 8? Because it just means 2 times itself 3 times. So let's talk about the order of operations. Whenever we do math, there is a rule, and the rule says that some operations are stronger than others. Now, operations are just things we do in math. Like some things we've done in math so far, if I go through my examples, here we multiplied 3 times 5, so multiplying is an operation. Subtracting is an operation. Here, squaring is an operation. Absolute value is an operation. Cubed is an operation. And so anything we can do in math with numbers is considered an operation. However, some of them must happen before others. Some of them are stronger than others in math. So here is the order of operations. If you learn PEMDAS, please go watch the video on the difference between PEMDAS and GEMS, which I'm about to teach right now. But GEMS is the order of operations. The strongest thing you always do first is any grouping you have. Grouping means combine into one number. There are many things that tell you that you have to combine everything into one number. The most common one is parentheses. If you see parentheses anywhere, it means anything inside the parentheses you're supposed to combine into one number first. They're not the only, so this is what parentheses look like. They're not the only thing that tells you to group though. Brackets tell you to group, which look like that, or like that. Absolute value tell you have to group them first before you can do the absolute values thing. So anytime you have these guys, you have to group first. Radicals, something else that tell you to group. Radicals kind of look like this. They have that little house symbol, and you have to group everything under there into one number first. Fractions are also grouping, because when you have intense fractions where there's tons of math up here and stuff, and then tons of math on the bottom, secretly you have to put the entire top, the whole numerator, into one number first, and then everything on the bottom has to turn into one number as well. So it's like there's secret parentheses on top and bottom that tell you have to group the whole denominator together and the whole numerator together first. So anytime you see a fraction, you must group each part first in order of operations. Grouping is always the first thing you do. You have to combine things into one number if you're told to. Once everything's in one number, the next strongest thing is E for exponents. So exponents are the little things up here. And so once you have this into one number, like a 2, then you're allowed to do the exponent where you times them together. In a weird way, absolute value works like exponents too, because once it's one number, then you take the absolute value of it. So once you have one number, you do those exponents. Then M stands for multiply / divide. Multiplying and dividing are the same thing. There is a skill building video to convince you of that if you don't believe me. But the best way to think about it is that if I were to take 10 and multiply it, to the fraction 1/2. Here I'll show you in Desmos what happens. 10 times to the fraction 1/2 equals 5. So even though I'm multiplying, it went down. But also, if I do 10 divided by 2, 10 divided by 2 is also 5. So all dividing is multiplying by a fraction. So that's the next strongest step in order of operations. The weakest thing and the last thing you do, S stands for subtract. Add. Again, subtracting and adding are the same thing. Subtracting is just adding a negative number. So one is not stronger than the other. They are equal weight. For both of them, you do what comes first when you read left to right. So you always read equations. You start on the left and you move to the right. And if you, whatever comes first when you read it, multiply or divide, you do that first. So let's talk about evaluating functions. If you remember in the what is a function's note, you can take your y and replace it with f of x. And f of x also just means output. So if I scroll all the way back to the top, it says output y, it's also f of x. Because remember, they mean the same thing. The reason why we use function notation like this, because this is called function notation, and the reason why we use it is because I know this one is called f, this equation right here, 3x minus 2. And it's different than the equation that's called j. So this one's called j because of the j in front. And j's equation is 5x squared minus 1. And this one's called m. And so m is x cubed plus 3. And then z is the absolute value of x minus 4, and then plus 5. So we can tell them apart based on their name. And remember, in the parentheses, it's just telling you that right now in the input spot is an x. So for all of them right now in the input spot is an x. Remember, it doesn't have to be an x. I could have used like a t here if I wanted, but that means this x would have been a t. And sometimes they do use other letters besides x, but x is the most common. So let's talk about evaluating functions. So instead of saying plug in 3, they're going to do this, f parentheses 3. So what it means is for the function named f, because it's the f, they want us to plug 3 into x. So I have to take this equation, 3x. So for f of 3, I'm going to take its equation, which is 3x minus 2. And instead of x, I just put a parentheses there. Because now what they're telling me to put into my input spot is a 3. Now, according to order of operations, to solve this, so for f, when I plugged in 3, it's going to equal, in order to solve this, first for grouping, do I have any grouping? No, I do not, because everything's already one number. Like if there was more things in this parentheses, then I would have to group them, but there's not. So I have no grouping. Do I have any exponents for the e? No. Let's see. Next, m, do I have any multiplying or dividing? I do, because 3 parentheses 3 means to multiply, and 3 times 3 is 9. Then I have minus 2. So finally, for f, when I plugged in 3, I get 9 minus 2 is 7. So that's how you do one of these. The other type of question I can ask you, so this one, they gave me the x, what they wanted me to put in for the x. Sometimes they might ask it like this, where they say find x. So they want us to figure out what x is if the equation equals 28. So what that means, they're telling us what f of x equals. They're telling us the output, the answer. So if the answer is 28, what is the x? So to do that, well, they're saying f of x, so I have to take that f of x again, the 3x minus 2. But this time, 28 is the f of x from the beginning, because this was f of x equals, but they're saying that equals 28. So I could replace this as 28. And now they're asking what is x, which means solve for x. So our last unit comes into play right away. You're going to do solving for x all the time. So to solve for x, what is my first step? I add the 2 to both sides. On this side, it'll cancel. Over here, 28 plus 2 is 30, equals 3x. And then now, what's my next step? I divide by 3 on both sides. 3 divided by 3 cancels and turns into 1x. And 30 divided by 3 is 10, equals the 1x. So the answer is 10. X equals 10. So if they ask for your answer in words, for this one here, you would say if the output, because it was about the answer, is 28, and output is our big word for answer, or our big word for the y. Remember, this is what it was equaling, so that's the y. So if the output's 28, then the input, so the x, is 10, because that's what we figured out. And that's how we do the answer in words. So now I have tons of questions. Remember, so there's always the long way to do math, and then there's the short way, because mathematicians like to go fast. So often they're going to give instructions like this, where it just says find j parentheses negative 2. And what it means is you take the equation j and you plug negative 2 into x. And so I'm going to go up quickly and grab all of these from the top so that we can see them as we do them. So this one says j equals negative 2. So I'm going to come grab the j of x1. And this time, instead of j of x, it's j of negative 2. Which means instead of x, I'm going to plug in what? Negative 2. And then I still have my parentheses being squared because the x is getting squared. And then I still have the minus 1. So to run through order of operations, gems, G for grouping. Do I have any grouping? No, because they're all one number already in each part. E for exponents. Do I have any exponents? Yes, negative 2 is being squared. And squared means negative 2 times negative 2. So if I do negative 2 times negative 2, a negative times a negative is positive, and 2 times 2 is 4. So now I've done exponents. Next, M for multiply / divide. Do we have any multiplying / dividing? Yep. 5 parentheses 4 means 5 times 4, and that's 20. And my last step is to add / subtract. And 20 minus 1 becomes 19. So if I'm told to write my answer in words, it would be for the function named, what's its name? J. If the input is, what was our input? Negative 2. Then the output is, and what was our output? 19, because that's the answer we got at the end. All right, this one says M parentheses 2. So I take M. And in my parentheses, instead of x, I'm going to put 2. That means instead of x, I'm going to put a parentheses. And I'm going to put 2 in that parentheses. And that parentheses is going to get cubed because x is getting cubed. And then I still have plus 3. So 2 cubed means 2 times 2 times 2. So 2 times 2 times 2 is 8. And then when I do 8 plus 3, I get 11. So if I was asked to put my answer in words, how would you write it? Go ahead and write out the whole thing you'd think you'd have to write. Try to copy this part here, but replace it with the things for this question. So I'm going to copy and paste it. For the function named, except this time it's named m. The input is, this time it was positive 2. And the output is 11. This one says find z of negative 3. So I'm going to take z. Instead of t, I'm going to put a parentheses with a negative 3 there. And then I'm going to add 5. So t worked no differently than if it was an x. Z, when I plug in negative 3, is going to equal, since there's nothing in front of this parentheses, there's no number to multiply, nothing like that, I can drop the parentheses. So it's just negative 3 minus 4. Negative 3 minus 4 is negative 7. So next, what do I do to that negative 7? What do the lines around it mean? It means to take the absolute value, which means to turn it positive. Since I turned it positive, the absolute value signs can go away. So finally, when I plugged in negative 3, I'm going to get out 7 plus 5 is 12. I'm not going to do answer in words for that one. For this one, though, it's slightly different. This one says find x if f of x equals negative 8. So let's go grab f of x. But this time, instead of saying x is negative 8, it's saying the f of x is negative 8. So where do I put the negative 8? It goes in front, replaces the f of x part. And now it's saying find x, which means solve for x. So what's my first step in solving for x? Add the 2 over to make it cancel here. Negative 8 plus 2 is negative 6. Then equal to 3x. Then my final step in solving for x is to do what? Divide by the 3. Negative 6 divided by 3 is negative 2. 3 divided by 3 will cancel, and we just become 1x. So x is negative 2. So if I had to put this answer into words, it would be very similar to one of these, except for the function named, this time it's f. However, it's not if the input, because they didn't give us the input this time. This time they gave us the output. So it's if the output, so if the answer is negative 8, because that's the output they gave us, then the input, the x we found, is negative 2. All right, so this is how it works for equations. It's a lot easier on tables and graphs. So I'm just gonna, as long as you know how to read tables and graphs, it goes pretty easily. So this is on a table. They're calling this table H. H of X is the table below. So this table right here is H. They want to know what is H of 0. So if it's in the parentheses, is that 0 X or Y? It's going to be x. So you need to find in the table where x is 0. Look right here. So the y in this table is a side-by-side one. So the answer is -2. H of 0 equals -2. You could write it all out. You don't have to. This one says, what is x when h of x equals 0? So this 0, is it going to be the x or the y? This one's going to be the y. So you go to y, and you look down and find where it's 0. Oh, look right here. And so the x with it is 4. When it equals 0, x equals 4. What is h of -2? That -2 is going to be x or y. It's going to be the x. And so what is the y with the x of -2? If you look side by side over here, it's -3. And then finally, what is x? If the equation equals -2, is that -2 this time going to be the x or the y? This time it's the y. And so where is the y -2? What's the x with it? 0. X equals 0. So that's on a table. On a graph, so if you look here, it's saying the graph below is S of x. Remember, x is the left and right axis, and y is the up and down axis. So in this case, when it says, what is S of -2? Is that -2 going to be my x or my y? It's my x because it's in the parentheses. So if I look at my x, here's 1, here's 2. Then I have to go up to where the green graph is. And it's telling me my y right now. Like if I tried to look over, I'd have to estimate, but above it, it's saying it's 53. If that 53 is not there, you would just have to estimate, like about where. If this is 40, this is 60. This line right here is in the middle, so that has to be 50. And then if you guessed anywhere between 50 and 55, you would have probably gotten credit. But since they gave you the answer, 53. So this one says, what does x equal when the graph equals 59? So that means what? Is 59 the x or the y? It's the y. So I take my graph and I go up to where y is 59. So here's 60, so a bit below that. And I go over and try to find my x. And look, this one's even labeled at 59. So what's the x of this point? If I go down, I see that the x, it was at 5 for that point. So in this case, x equals 5. All right, for S of 6, is 6 going to be my x or my y? My x. And if I go over to my graph where x is 6 and go up, I find my y to be what? It's labeled at 67. And finally, this one says, what is x when the graph equals 43? So that 43 is at x or y? Y, so I go up to where it's 43. Oh, look, it's this point right here. And what's my x for this point right here? It's saying it's 1. 1. All right. And that's everything. Remember, if you had to put this into words, it'd be something like, for example, if I said for this one, put it into the words, you would say for the function name s, if the output is 43, then the input is 1. And that's the basic structure. So in your own words, explain what you learned how to do in this lesson.